first of all, that if we have a curve 3x square minus y square minus 2x plus 4y equal to 0, and we have different chords for this curve. Now we have to actually prove that these chords subtend a right angle at the origin. So how to do it? Now we are going to use the concept we have just studied to solve this problem. Now the given curve is 3x square minus y square minus 2x plus 4y equal to 0. Let us say that y is equal to mx plus c is any chord of this curve. So it intersects this curve at two given points. Now we have to prove in this problem that this particular chord extends right angle at the origin. This angle is 90 degrees. Or in other words, I can say that we have to simply prove that these two lines are perpendicular to each other, and the best point is these two lines pass through origin, and these two pass through the intersection of y equal to mx plus c and the curve 3x square minus y square minus 2x plus 4y is equal to 0. Now this is very much similar to what we have actually studied. So once again, y equal to mx plus c, or I can write as y minus mx by c equal to 1. The equation of curve is 3x square minus y square minus 2x plus 4y equal to 0. Now we are going to make it homogeneous. So 3x square minus y square minus 2x into y minus mx by c plus 4y into y minus mx by c equal to 0. It further gets simplified to 3c plus 2m into x square minus 2 times 1 plus 2m into xy plus 4 minus c into y square equal to 0. Now it has been given that these lines are perpendicular to each other. So these two lines are perpendicular if the coefficient of x square plus coefficient of y square is equal to 0, or the coefficient of x square is 3c plus 2m here, and the coefficient of y square is 4 minus c. So 3c plus 2m plus 4 minus c equal to 0, or c plus m plus 2 is equal to 0. Let us say this is equation number 1. Now we have equation y equal to mx plus c. I put point 1 comma minus 2 over here. I get as minus 2 equal to m plus c, or c plus m plus 2, which is ultimately equal to equation number 1. Thus I can clearly say that y equal to mx plus c passes through this point 1 comma minus 2. Now 1 comma minus 2 is a fixed point, it is not a variable point. So y is equal to mx plus c always passes through this point 1 comma minus 2. Once again we have the equation 3x square minus y square minus 2x plus 4y equal to 0, and let us say the chord is given by y equal to mx plus c, and we have to make this equation homogeneous. So we get as 3c plus 2m into x square minus 2 times 1 plus 2m into xy plus 4 minus c into y square equal to 0. Now the lines represented by this equation are perpendicular if coefficient of x square plus coefficient of y square is equal to 0. So 3c plus 2m plus 4 minus c is equal to 0, or c plus m plus 2 equal to 0. Now the equation of the chord is y equal to mx plus c. If I put 1 comma minus 2 over this equation, I get as c plus m plus 2 equal to 0, which is actually true by equation number 1. Hence I can always say that y is equal to mx plus c passes through the point 1 comma minus 2, and which is a fixed point. Now students, we are going to understand the concept of locus. Now locus is a term we are going to use in the entire coordinate geometry. So let's understand what exactly is a locus. We can define locus as the path of a moving point when it moves in a plane under certain geometric conditions. Now if there is a point and it satisfies certain geometric conditions, so the trajectory followed by that point, or the path followed by that point, would be the locus of that point. Now how we are going to find the locus of any point? So let's look at the procedure to find the locus of point. In the first step, we assign coordinates h comma k to the point for whose locus we are interested in. Then we express the given conditions as equations in terms of the unknown and the known quantities. In the third step, we eliminate unknown and express it in the terms of known and h comma k, and finally we replace h by x and k by y. Once again, we assign coordinates h comma k to the point for whose locus we are interested in. Then we express those conditions in terms of equations by unknowns and known quantities. Then we eliminate such unknowns and express the equation in terms of known and h comma k, and in the final step we replace h by x and k by y. So let's look at an example to throw more light on locus and understand this concept more clearly. Now this problem appeared in IIT JEE 2002, and it says that a straight line L through the origin meets the line x plus y equal to 1 and the line x plus y equal to 3 at P and Q respectively. Through P and Q, two straight lines L1 and L2 are drawn parallel to 2x minus y equal to 5 and 3x plus y equal to 5 respectively. The lines L1 and L2 intersect at a point R. Show that the locus of R as L varies is a straight line. So in this problem we have been given that a line through the origin meets the line x plus y equal to 1 and x plus y equal to 3, and this line intersects these two lines at points P and Q. Now through P and Q, two straight lines L1 and L2 are drawn, and this line L1 is parallel to 2x minus y equal to 5 and the line L2 is parallel to 3x plus y equal to 5. Now again these two lines intersect at a point R. Now we have to show that the locus of R as L varies is a straight line. So let's look at the solution of it. Now let us say the equation of L be y equal to mx. Now this is the line that passes through origin, so we can write it as y equal to mx. Now it is given that y equal to mx intersects the line x plus y equal to 1 and x plus y equal to 3 at the points P and Q. So the coordinates of P would be 1 by m plus 1 comma m divided by m plus 1, and the coordinates of Q would be 3 divided by m plus 1 comma 3m divided by m plus 1. Now these are the coordinates of P and Q. Now it has been given that we draw lines passing through P and Q but parallel to L1 and L2. Now the slope of line L1 is 2 and the slope of line L2 is equal to minus 3.
So the equation of L1 becomes y minus m by m plus 1 equal to 2 times x minus 1 divided by m plus 1, or we can reduce it as y minus 2x equal to m minus 2 divided by m plus 1. Let us say that this is equation number 1, and similarly the equation of line L2 becomes y minus 3m by m plus 1 equal to minus 3 into x minus 3 divided by m plus 1, or we can further simplify it as y plus 3x equal to 3m plus 9 divided by m plus 1, and we name it as equation number 2. Now we have to find the intersection point of these two lines. Let us say that this point is R. So we can find the intersection point by eliminating m from these two equations. So from equation number 1 we get the value of m equal to y minus 2x plus 2 divided by 1 plus 2x minus y, and from equation number 2 we get the value of m equal to 9 minus 3x minus y divided by y plus 3x minus 3. So what we do is we equate these two terms so that we get as x minus 3y plus 5 equal to 0. Now this is an equation of a straight line, and this represents the locus of R. Thus we can say that the locus of R, which is the point of intersection of L1 and L2, is a straight line. So students, with this we come to the end of our first lecture on coordinate geometry. This chapter forms a very basic of coordinate geometry, and so it becomes very much important for you to understand it with much of clarity. So try to apply these concepts taught while solving many of the problems. For more doubts and queries, you can visit our site www.topiitcoaching.com. We are committed towards perfecting IIT preparation. Thank you.
Hi students, today we are going to study about circles. Circles have been an integral part of our day-to-day lives, from the rim of a bicycle to the ring in your finger, from the bangle in your mother's hand to the path of electron around the nucleus. We find circles everywhere. Circles have revolutionized our world, so it becomes very necessary to know about their properties. So let's learn more about circles.
So students, what exactly is a circle? I'm pretty much sure that every one of us knows what a circle is because we come across it all the time in our daily lives. But as this lecture is entirely based on circles, so let's define it. A circle is defined to be the set of all points in a plane that are at a fixed distance from a fixed point. Now this fixed point is called the center of circle and the fixed distance is called the radius. Hence, a circle is completely determined by the coordinates of its center and the fixed distance of the points from the center.